The Chapter 9 exam review video. Get your exam review, but also your note card and notes and things that you think would be helpful to working on this. So the first set asks you to solve using the square root property. The idea that if we have an equation and we want to solve, we might be able to just take the square root of both sides if it's in a certain condition. So to check, we need to check that we isolate that squared amount on one side. When I look at number 3 does not have a squared amount isolated. I see a squared amount in there. I see that x plus 2 quantity squared right here, but it's got a plus 7 with it. In number 1, I do see a squared amount already isolated, and in number 2, I do see a squared amount already isolated. So that first step would already be done for number 1 and number 2. But for ours, we would need to subtract 7 in order to have the squared quantity isolated or alone on one side. So 14 is not the squared quantity, it's that x plus 2, quantity squared. So that's what step 1 is talking about. In step 2, which number 1 and number 2 are both ready for right away, it says once we're down to a perfect square on one side, we want to undo that perfect square side. So as I'm looking at the perfect square side, I want to undo the squaring on that. So the way that we do that mathematically is we take the square root of both sides. So I'm going to take the square root of that squared side and then the plus or minus the two different square roots of 14 that we would have. So that's why there's that reminder, use plus or minus for the two different square root values of the positive number that you're taking the root of. So on the highlighted side, the x plus 2 quantity squared side, the square root and the square undo each other, and we are just left with x plus 2. They are inverses of each other. When we go to take the square root of 14, I'm going to put plus or minus square root of 14 here. It's a value that's not rational. It's a decimal value that we'll round off in a second. But now I need to split this because there's two answers that x plus 2 could also be. So that third step says split into two equations and solve each. So x plus 2 could be the positive square root of 14, and x plus 2 could be the opposite, or the negative value that square root of 14 might have. So this would be the time then to solve those two separately, going to my calculator and getting a decimal value. So for this one, when I go and I actually take square root of 14 and subtract 2, I should come in around 1.7. And you need to take this last one and finish solving that and get the value that that comes to. So pause the video, finish the ones in that set using these 3 steps, and then come back. So in number 4, the directions above say the learner can use the discriminant to determine how many solutions it has. So they ask us to take the discriminant and to solve and get the number of solutions to this. So the equation that they give us in this one is quadratic and it's already equal to 0 so that I can identify in standard form my A value, B value, and C value. So as I know that I need to do this, as long as it's equal to 0, then I can tell that the A value for this quadratic equation is 2, the B value is negative 8, and the C value is negative 24. If it's not already in 0 equals form, then I would need to actually go and move it into that form before I can find those. The discriminant is the part of quadratic formula that's underneath the square root sign, and this would be an important one for your note sheet. So the discriminant formula is going to be that b squared minus 4ac value. And when I go to calculate that part of this for our particular one, we're going to get, so b squared would be negative 8 quantity squared, make sure it's in parentheses, minus 4 times our a quantity times our c quantity. And when we get that value, okay, and you can write the value in there, we should be able to tell if our final solution, our final answers would have 1, 0, or no solutions to our quadratic equation. So as soon as you get that discriminant value, then you want to think about 3 different possibilities and then answer the final question. So if the discriminant's positive, that tells me that we'd have 2 solutions to our quadratic equation. If the discriminant is 0, that tells me I'd only have 1 solution. And if the discriminant is a negative number, it tells me that I would have 0 real solutions to the equation. So be sure to finish this one and then answer based on that discriminant value what you would have. Once you do that, then you need to go and actually solve using quadratic formulas. So there's multiple parts to this. Then we actually need to solve. And here's again where we want to get back to that idea about how we get x's out of the quadratic formula and make sure that you have that formula on your note sheet because that formula will not be provided. So as I look at the formula to generate solutions to a quadratic equation, then I want to see if I can get our particulars in for our quadratic equation. Opposite of b in our case, our b value is negative, so its opposite's going to be positive. Plus or minus square root of, you're going to put the number in there that you got up above as your discriminant value. And then divided by 4. So make sure that discriminant that you got goes under there. Then you need to go through and actually solve that. Once with the 8 plus the square root of your discriminant divided by 4 and get a number. And the other one's going to be using the subtract. 8 minus the square root of your discriminant divided by 4 to get your answer. So be sure to finish that. In number 6 then, they ask us to go find the vertex and 2 other points in order to graph this equation. So I selected the b value. And in this one, I'd want to go over on the side, put what I know about my quadratic equation. My quadratic equation, when I first see it, I need to double check that if it's in that standard form or not so that I can tell its a value, its b value, and its c value, and ours is. So what I know is that the a value here is going to be -1, the b value is 2, and the c value is -3. You had lots of graphing features that you knew had to be true based on those values. And so a lot of these formulas are things you would want to be sure that you get onto your note card. So the axis of symmetry is always an equation, and it's always a vertical line, and it always has that formula that it comes from the opposite of our b value divided by twice our a value. In our case then, we would be switching to our particular equation. Our opposite of our b value is -2. Twice our a value would be 2 times -1. -2 divided by -2. So our particular equation for our axis of symmetry puts that axis at x is 1. And when you graphed before, you put that middle line down. It's not actually part of your parabola, so it's dotted as if it's not really there, marking the halfway on each side of our parabola. We do know is that the vertex has to be on that line. So in our case, we know that our vertex has to have an x-coordinate of 1. It's that exact value. Then we need to go back to the function up here and actually put that x value in as 1 and calculate what the y would come out. So the y we seek is going to be that -1 times our input of 1 squared plus 2 times 1, -3 or plus -3 if you will. And we should have our vertex at 1, -2. So I'm going to go put that in on my graph. When I go to get the y-intercept, that again comes from my equation. So when I go to get the y-intercept's always at 0, the c value from our equation. So in our case, that's going to put our y-intercept at 0, -3. I'm going to go ahead and put that point in. Then we need at least one other point. Sometimes we need to go back and plug in additional x's, but in this case, I think we can find it by using a little symmetry. So if it is 1 unit to get from my point that I knew to my axis of symmetry, then I go 1 unit on the other side of that axis of symmetry, and I have that reflected point. In our case, its coordinates are at 2, -3. And therefore, I can go ahead, and if they only require 3 points, I can go ahead and put in that curve, that parabola. Remember, it's a smooth curve, no pointies. And then I can answer some additional questions about domain and range. So domain is about x values used, and that graph will continue to get wider and go to bigger x's and smaller x's. So our domain in this case happens to be all reals. Our range, though, is not, and I want to look at the vertex when I think range. The vertex is at 1, -2. And all the points on the parabola are lower than that. So that y value right there is really important. I know that that -2 is the deciding line for the y values. Values on one side of -2 are on this parabola, values on the other side of -2 aren't. So our range states what is, so we need y's that are less than, or they could be exactly -2 to have all the y values for our parabola described. And finally, when we get to number 7, we should be able to describe this graph and use all those features that we did, pausing this where you can. So you should be able to tell if it opens up or down by your A value. So we should probably go back and check. Our A value here is 1. Our B value here is -1. Our C value is -2. So we can tell from our A value being positive that this should open up. We should be able to tell from 0, C what our y-intercept is. So we should be able to tell our y-intercepts at 0, -2. We should be able to calculate our vertex by using that opposite of B over 2A formula to begin and get our axis of symmetry. So in our case, opposite of B divided by 2A is going to come up 1/2, or 0.5 if you prefer. So I know my vertex starts at half. You're going to pause the video, go use the 1/2 in our y = equation, and go find out what that y is when we take 1/2 and square it. Subtract our x value, and subtract 2. I'm just using the equation with our particular input. Pause the video and come back when you've got the number. Right. -2.25. From there, we should be able to go back to earlier in the video, we discussed discriminant. So you should be able to go calculate that on your own using your A, B, and C value. I should be able to make a rough plot of this graph using the information that I found about my y-intercept, my initial ordered pair, and then my axis of symmetry running right down through x's half tells me that I've got another point right there. Now I'm going to have to do some estimating here as to where the rest of the points are, and I don't like that. To make this parabola, they want to know how many solutions and what they are, so I need additional x values. So I have 3 ordered pairs on my graph already, but I can't tell whether the graph should cross like here, the graph should go wider. So in order to tell that, we're going to go calculate a few more points on this parabola. So I think we should find out what happens when x is 2, because it's nearby and we don't know that. So for x is 2, we go back to the equation and we'd be looking at 2 squared minus 2 minus 2. That got me 0. So I know that 2, 0 is a point on my graph. If I can count how far it is to my axis of symmetry, I can put one more point on there. So it's 1 whole box and half a box to get to my axis. So half a box and 1 more whole box. I should be able to put that additional point on my parabola. Now I've got a really clear idea of what my parabola looks like, and this is going to help me tell what the solutions are. So as far as number of solutions, I need to count the number of x-intercepts. And then as far as what the solutions are, I need to list those x-intercept values. X is what, and x is what. And there should be 2. Then you can go back and get domain and range to finish this up.